When we think about AI, we usually hear bigger is better. The goal seems to be one giant, super smart model that lives in the cloud. But what if that's not the whole story? What if a team of smaller, more specialized AIs running right on your own computer could actually get you a better, more accurate answer? Let's dive into a really fascinating paper that explores exactly how this new approach works.
And that really is the big question, isn't it? For years, the race has been all about building the biggest, most powerful AI possible. But that strategy comes with some serious downsides. Things like privacy risks, huge costs, and giving up control of your data. So we're going to look at a totally different way of thinking that challenges that whole bigger is better idea.
Okay, so this really lays out the two different philosophies, right? On one side, you've got that massive cloud AI. It's incredibly powerful, for sure, but you have to send your data to it, and it can get really expensive. On the other side, you have this idea of a local team of AIs. With them, your data stays private, you have total control, but everything, and I mean everything, hinges on how well they can work together as a team.
All right, so if teamwork is the secret sauce here, how do you actually make it work? Well, that leads us right into the core concept behind all of this research, taking that classic idea of the wisdom of crowds and applying it to artificial intelligence.
And this idea, it's not some crazy new thing. We've known for a long time that if you ask a big enough group of people a question, their average answer is often way more accurate than what you'd get from a single so-called expert. So this research just asks a simple question. Can we do the exact same thing, but with AIs?
And this brings us to the official name for this setup, an LLM Ensemble. Now, this isn't just one AI trying a bunch of times. No, this is a real team, made up of different models of different sizes and designs, each bringing its own unique viewpoint to the problem. And the best part? It all happens locally, so your data never has to leave your own network.
So how is this whole thing built? Well, you can think of it as having two main players, a manager and their team of specialists. It's actually a pretty elegant design.
First up, you've got the orchestrator. This is basically the project manager. It's the one that listens to your question, sends it out to the whole team, and then gets stuck with the really hard job, taking all these different answers and figuring out which one is the right one. And then you have the agents themselves, the specialists on the ground. For this study, the researchers used 4 really well-known open-source models. Now, you don't need to memorize these names. The key takeaway here is diversity. Each of these models thinks a little differently, so you're not getting the same opinion 4 times. You're getting a real panel of experts.
Okay, so let's follow a single question on its journey through this whole system. It's actually a pretty straightforward 6-step process. You send your question to the manager, the orchestrator. It immediately sends that question out to all 4 agents at the same time. They all get to work, come up with their own answers, and send them back. The manager collects everything, and then, and this is the most important part, it uses a specific strategy to choose the best answer to send back to you.
Okay, this is where things get really cool. You've got 4 different answers coming in. How in the world does the orchestrator decide which one to go with? Well, the researchers didn't just pick one way. They tested 5 different strategies to figure out what works best. And these strategies go from super simple to pretty complex. You've got majority voting, which is just like it sounds. The most popular answer wins. Then there's weighted voting, which is a bit smarter. It gives more of a say to the AIs that have a good track record. Then you get to this one, inverse surprising popularity, or ISP, which is super clever. Basically, it looks for answers that are more common than they should be, which can help uncover a hidden correct answer. Topic routing is like sending a specific task to your team's expert. And finally, debate, where the AIs literally argue with each other to find the best solution. So you can really see this as a spectrum, right? And it all comes back to that classic trade-off. On one end, you've got majority voting. It's fast, it's simple, it's democratic. On the complete other end, you have the debate. It's way more thorough, and it's trying to find the absolute most accurate answer. But, as you can probably guess, all that back and forth takes time. All right, time for the main event. We have the team, we have the strategies, so how did they actually do? The researchers put this whole system through its paces, using standardized AI benchmarks. You can think of these as really tough exams that measure an AI's skill in things like math, logic, and telling fact from fiction. So, this is it, the big reveal. Does all this fancy teamwork actually make a difference? Does it pay off in the end? The researchers tracked everything, so let's get right to the numbers.
And boom! Here are the accuracy results. Check out the orange bars, that's grade school math problems, and the green bars, which test for telling the truth. You can see it clear as day. The smarter strategies, like weighted voting and ISP, they get way more answers right than a simple majority vote. So yeah, smart teamwork definitely works.
But of course, there's no free lunch. This next chart shows us the speed, or what the researchers call latency. And wow, just look at that huge spike for the debate strategy on the right. It gets great answers, but it takes a ton more time to do it. We're talking almost 4 times slower than the others.
And this just perfectly captures the core dilemma, doesn't it? It boils down to one simple question. Do you need the absolute best answer, or do you need a really good answer right now? The beauty of a system like this is that it lets you make that choice depending on what you need.
And just so we're crystal clear, these accuracy boosts, they're not just random chance. The researchers ran all the numbers. And as you can see from this table, the improvements they saw from using the smarter strategies were all statistically significant. This is real, hard data. It's proof that the system works.
Okay, so let's pull back for a second. What's the big picture here? What does this all mean for the future of AI? Why does this research actually matter?
The really amazing thing about this paper is that it's not just a cool idea, it's a complete blueprint. They've laid out a real-world design for building private AI. They've given us a whole playbook of strategies for making group decisions, and they provided a full toolkit so other scientists can reproduce and build on their work.
So at the end of the day, what we have here is a roadmap. It shows us a path forward for building AI systems that are not only powerful, but also private, controllable, and affordable. It means we might not have to choose between having a smart assistant and keeping our data safe.
So it really leaves you with a fascinating question to chew on. As we look to the future, is the best AI going to be that single, giant brain sitting in a data center somewhere? Or could it actually be a small committee of experts, all working together, right inside your own device?